To my video on one-step inequalities with multiplication and division. So solving one-step multiplication, division, inequalities are similar to solving one-step equation. So notice the similarities here. First, we isolate the variable. To undo a multiplication inequality, we must do the opposite, which is divide. So look at our first example. 8y is greater than or equal to 24. We have a multiplication equation, so we're going to divide both sides by the number in front of the variable, which is 8. So essentially here we are using the division property of equality because we're dividing both sides by 8. So 8 divided by 8 is a 1 in disguise. Bring down your y, bring down your symbol, and 24 divided by 8 is 3. Always bring your letters straight down, always bring your symbol straight down, and always bring your calculations straight down. So y is greater than or equal to 3. So remember, 3 could be a solution, and anything greater than 3 can also be a solution because it's greater than or equal to 3. Okay, to undo a division inequality, we must multiply. So we have a fraction here, and the opposite of division is multiplication. So we're going to multiply both sides by 4. So let's demonstrate here. We're going to multiply both sides by 4. And because we're doing the inverse, these are going to cancel. Because remember, n divided by 4 is like 1/4. So we're multiplying by 4 using the multiplicative inverse property. So this is a 1 in disguise. N is less than 7 times 4 is 28. So n is less than 28. Remember the golden rule of algebra. What I do to one side, I must do to the other. Now, this next part is not going to be in your notes, but I'm going to do a quick demonstration to explain one of the rules that you have to remember when you're solving a multiplication or division inequality. So just follow along here. 6 is greater than 4. Is that true? It most certainly is. So let's add 2 to both sides. So 6 plus 2 is 8, and 4 plus 2 is 6. Is that true? It sure is. Now, let's subtract 2 from the original. So let me circle the original so you know we're doing it to that. So subtract 2. 6 minus 2 is 4. And 4 minus 2 is 2. Is that true? 4 is greater than 2. It most certainly is. And you guys already knew this. When you add or subtract from both sides, nothing happens to the symbol. Okay, so let's look at the next one. We're going to multiply both sides by 2. So 6 times 2 is 12. And 4 times 2 is 8. Is that true? It most certainly is. Now let's divide both sides by 2. 6 divided by 2 is 3. And 4 divided by 2 is 2. Is that true? It most certainly is. Now, I want to multiply by negative 2. So 6 times negative 2 is negative 12. 4 times negative 2 is negative 8. Is that true? Is negative 12 greater than negative 8? It is not true. So, how could we make this statement true? Good. We flip the symbol. So now, in this case, I would have negative 12 is less than negative 8. Now I've made it true by flipping the symbol. Okay, now let's look at dividing by negative 2. 6 divided by negative 2 is negative 3. 4 divided by negative 2 is negative 2. So is negative 3 greater than negative 2? Once again, how can we make it true? We have to flip the symbol. So whenever you multiply or divide both sides by a negative, we've got to remember to flip the symbol. Because remember, as positives go up, they get larger. Okay? But as negatives go, we go negative 1, negative 2, negative 3, negative 4. But the larger the negative, the smaller it is. Okay, so when we multiply or divide by negative, it changes its value. So we have to flip the symbol. Okay, now let's go back to our notes and remember this demonstration when we solve these problems. Okay, number 1. The opposite of division is multiplication, so I'm going to multiply both sides by 3. What happens to the 3's? They cancel. Bring down your variable. Bring down your symbol, and negative 6 times 3 is negative 18. Now notice I did not flip the symbol here. Why? Because I didn't multiply both sides by a negative. I multiplied both sides by positive 3. So no need to switch it when you multiply both sides by a positive 3, as you saw in the demonstration when I multiplied by positive 2. Okay, number 2. Oh, and also, when you do these, make sure you're checking these. And since I'm dividing by 3, I'm going to pick something less than or equal to negative 18. I'm going to pick a multiple of 3, so I would check negative 21. Negative 21 divided by 3 is negative 7, and negative 7 is less than or equal to negative 6. So make sure we are checking these. All right, number 2. The opposite of multiplication is division, so I'm going to divide both sides by 4. 4 divided by 4 is a 1 in disguise, so cancel it. Bring down your x, bring down your symbol, and negative 32 divided by 4 is negative 8. Notice once again I did not flip the symbol because I divided both sides by positive 4. So now we have to pick something less than negative 8, so I'm going to try negative 9. 4 times negative 9 is negative 36. Is negative 36 less than negative 32? It is, so put a check mark. We're good to go. Number 3. Notice there's a negative in front of the variable, so I have to divide both sides by negative 3. Negative 3 divided by negative 3 is a 1 in disguise, so cross them out. Bring down your x, and ding, 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 we have to flip the symbol. Why? Because we're dividing both sides by a negative. So flip the symbol, and 21 divided by negative 3 is negative 7. So we have to check something less than negative 7. I'm going to choose negative 8. So negative 3 times negative 8 is 24. Is 24 greater than 21? It sure is. Put a check mark. Okay, number 4. We have a negative in front of the x, but no number. So remember back when we did equations, what did I tell you to put in front of the x? Good, a 1. So now we have negative 1x is greater than negative 15. So we're going to divide both sides by negative 1. Negative 1 divided by negative 1 is a 1 in disguise. Bring down your x. Ding, ding, ding. We have to flip the symbol because we're dividing both sides by a negative. So flip it, and negative 15 divided by negative 1 is 15. So x is less than 15. Let's check it. Pick something less than 15. So I'm going to choose 14. So negative 14 is greater than negative 15. Yes, that's true. So put a check mark. And let's write flip here and flip here. These are the only two we flipped. And why? Because in this one we divided both sides by a negative, and this one and both of these, we divided them both by negative. Sorry. Okay, let's move on to number 5. So turn the page. Now remember when we did one step, if we saw a negative in front of the fraction, we just moved it to the bottom here. So we have x divided by negative 4. The opposite of division is multiplication, so I'm going to multiply both sides by negative 4. These cancel because I'm doing the inverse property. Bring down your x and ding, 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 we have to flip the symbol. 9 times negative 4 is negative 36. So x is greater than or equal to negative 36. Now, why did I flip the symbol? Because I multiplied both sides by a negative. So write flip here, just for our purposes that why we're flipping these. So when you look back at your notes, you can see why. Now we have to pick something greater than or equal to negative 36. Since we're dividing by negative 4, I'm going to pick a multiple of 4, so negative 32. So negative 32 divided by negative 4 is 8. Is 8 less than or equal to 9? It sure is. Put a check mark. Okay, number 6. The opposite of multiplication is division, so we're going to divide both sides by negative 12. Negative 12 divided by negative 12 is a 1 in disguise, so cross them out. Bring down your x and ding, 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 flip the symbol. Negative 96 divided by negative 12 is 8, so x is less than 8. Now, once again, why did I flip the symbol? Because I divided both sides by a negative. So we're going to pick something less than 8, so I'm going to choose 7. Negative 12 times 7 is negative 84. Is negative 84 greater than negative 96? It sure is. Now, if you feel comfortable with the 6 examples we've done, go ahead and pause the video and see how you can do on your own. Okay, welcome back. If you pause the video, let's see how you did. The opposite of multiplication is division, so divide by 5. 5 divided by 5 is a 1 in disguise. Bring down your x, bring down your symbol, and 35 divided by 5 is 7. So to check it, let's pick 6. 5 times 6 is 30, and 30 is less than or equal to 35. It checks. Okay, the opposite of multiplication is division, so I'm going to divide by negative 4. The negative 4s are going to cancel. 1 in disguise. Ding, ding, ding. We have to flip the symbol because I divided both sides by negative 4. 36 divided by negative 4 is negative 9. And guys, go ahead and add the negative here. I added that late, but we are dividing both sides by negative 4. And x is greater than negative 9. So we flip the symbol here. Now let's pick something greater than negative 9. I'm going to pick negative 8. So negative 4 times negative 8 is 32. Is 32 less than 36? It sure is. Put a check mark. Okay, let's look at the last 2 examples. We have a fraction. So we're going to multiply. Look at the denominator. The denominator is 3, so we're going to multiply both sides by 3. Because of the multiplicative inverse, these cancel. So I'm left with x greater than or equal to 14 times 3 is 42. Now notice I did not flip the symbol here because I didn't multiply both sides by a negative. So something greater than or equal to 42, I'm going to pick a multiple of 3 because I'm multiplying by 1/3 here. So 45 times a third is 15, and 15 is greater than or equal to 14. It does check. Okay, last example. We have a negative in front of the fraction, so we're going to move it to the denominator. And the opposite of division is multiplication, so we're going to multiply both sides by negative 2. Negative 2's cancel, 1 in disguise. Ding, 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 flip the symbol. And 16 times negative 2 is negative 32. Now remember, I flipped the symbol because I multiplied both sides by negative 2. Now we're going to pick something greater than negative 32, and because we're dividing by 2, I'm going to pick a multiple of 2. So negative 30 divided by negative 2 is 15. Is 15 less than 16? It sure is. So remember, when solving multiplication and division inequalities, solve them just like we did, one-step problems. But remember, when the variable is negative, we've got to remember to flip the symbol because we're multiplying or dividing both sides by a negative. That concludes our notes on multiplying and dividing inequalities. I hope you have a great day.